Hi, this is Matt B. and Nasir M. We're doing infrared.
Wavelength is 700 nanometers minimum to 1 max of 1 millimeter. Frequency is 430 terahertz to 300 gigahertz. This is just above the frequency of visible light.
Infrared radiation was discovered in Germany in the 1800s by astronomer Sir William Herschel. He discovered a type of invisible radiation in a spectrum lower in energy than red light. Slightly more than half of all light rays that travel from the sun are infrared radiation, and it is just above the field of vision for visible light.
Example of infrared in a household is a TV remote. The infrared light pulses form a pattern unique to the button. The receiver in the device recognizes the pattern and causes the device to respond. Another example of infrared in general is night vision goggles. Night vision goggles using thermal imaging technology capture the infrared light by emitting as heat.
Temperature regulation is very important in the medical field as many organs are dedicated solely to regulating body heat, and so infrared rays can identify where hot spots and cold spots are. This can be used to diagnose such things as heat stroke and heat apnea.
Fun facts about infrared are infrared means Latin below. Another example of a fun fact is infrared goggles allow military to look through thick smoke.
The links we use for this video are faxbarns.com, sciencedirect.com, and infraredcamerasinc.com. We're making an equation, we're trying to figure it out, and the equation is what is the wavelength of infrared light whose frequency is 1 times 10 to the 12th. Sorry, there's a typo in there. How do we figure that out? Well, let's begin. We would erase that and start off by doing c equals f lambda, and c equals 3 times 10 to the 8th, and f equals 1 times 10 to the 12th. Now we're trying to figure out what lambda is, so we have to do 3 times 10 to the 8th equals 1 times 10 to the 12th, lambda. You then divide the c by f, and that gives you lambda, and lambda is 3 times 10 to the negative 4. So in our last equation, we found wavelength, but now we're going to be finding frequency. And the equation is, what is the frequency of an infrared light whose waves have a length of 1 times 10 to the negative 12th. Now using this, we'd use the same equation as last time. C equals f lambda, c equals 3 times 10 to the 8th as it did. F we do not know, and wavelength is 1 times 10 to the negative 12. Take 3 times 10 to the 8th equals f times 1 times 10 to the negative 12. You divide your c, or 3 times 10 to the 8th, by 1 times 10 to the negative 12, which is what we did last time. The frequency ends up equaling 3 times 10 to the 20th. Alright, one thing that infrared radiation does is that it can harm the eye. This is especially prevalent in the electromagnetic radiation that is all light, but it's also in infrared. This causes damage to the cornea, and the chances of this are increased due to that the sun's waves, over 50% of them are infrared radiation, so staring into the sun obviously hurts your eyes, and that's due to the infrared radiation.
Another example that can harm the tissue or skin is laser beams. Laser beams are made of amplified electromagnetic radiation. The lasers can be strong enough to burn through metal or flesh.
Over 50% of all electromagnetic waves that come from the sun are infrared. These can severely damage the eye and the retina, damaging your eyesight. Now in this diagram it shows the blue infrared lasers going into the eye, therefore damaging it and making it so the retina is permanently damaged. The purple lasers represent the minority of all of the electromagnetic waves that come from the sun.
This is an infrared laser. It can burn through flesh. Number 1 is highly reflective. Number 2 is partially reflective. And number 3 is the medium.
These are the two books that we used in our project. The Conceptual Physics by Paul G. Hewitt. It's a high school physics program book. The second book we used was Holt Physics, Survey Fawn. It's by Holt, Reinhardt, and Winston.